Structure of atom. We will discuss about the numerical of structure of atom. So the first numerical is calculate the energy of a mole of photon of radiation whose frequency is 5 into 10 to the power 14 Hertz. The question is calculate the energy of a mole of photon of radiation whose frequency is 5 into 10 to the power 14 Hertz. So firstly we should come to know that what value we have given. We know the frequency and the frequency is 5 into 10 to the power 14 Hertz, and we have to find energy of 1 mole of photon, and we know that energy of 1 photon E is equal to h nu, and we know the value of h, which is 6.626 into 10 to the power minus 34, and nu is given, which is 5 into 10 to the power minus 14, and E will be 6.626 into 10 to the power 34 into 5 into 10 to the power minus 14, which will be 3.313 into 10 to the power minus 19 joule. Then it's the energy of 1 photon, but in question we have to find energy of 1 mole of photon. So energy of 1 mole of photons will be 3.313 into 10 to the power minus 19. ये हमारी 1 photon की है, and if we will multiply it with 6.022 into 10 to the power 23 per mole. Per mole means mole inverse. Then 19 value will be 19,951 joule mole inverse. If we want to it convert into kilojoule, then we have to divide it from 1000. Now our answer will be 19.951 kilojoule mole inverse. It's our final answer. Now the second question is two particles A and B are in motion if the wavelength associated with particle A is 5 into 10 to the power minus 8 meter, then calculate the wavelength associated with particle B if its momentum is half of A. Our question is two particles A and B are in motion if the wavelength associated with particle A is 5 into 10 to the power minus 8 meter. Calculate the wavelength associated with particle B if its momentum is half of A. So in this question we know the value of, firstly we have to assume that two particles which are A and B, and the wavelength of A particle is given, which is lambda A. We can write lambda is equal to 5 into 10 to the power minus 8 meter. Calculate the wavelength associated with particle B. So we have to find out lambda B, that what's the lambda of B particle, and particle B if its momentum is half of A. And if we assume that the momentum of A is PA, then the momentum of the momentum of B will be half of PA. So by de Broglie equation, we know lambda is equal to h upon P. If we talk about A particle, then its wavelength will be lambda A is equal to h upon PA, and lambda B will be h upon PB. If we do lambda A upon lambda B, then it will be h upon PA upon PB upon h. So h will be cancelled and will give us PB upon PA. So, and we know that PB is equal to half PA, so we can put the value of PA which is half PA. Then lambda A upon lambda B is equal to half PA upon PA, which will be equal to half. Then lambda A upon lambda B will become equal to half. And we know the value of lambda A, and we have to find out lambda B, which will be 2 into lambda A. So lambda B will equal to 2 into lambda A. The value of lambda A is 5 into 10 to the power minus 8 meter. So lambda B will be 10 to the power minus 7 meter. And it's our final. Now the third question is, if an electron is moving with a with a velocity 600 meter second inverse, which is accurate up to 0.005%, then calculate the uncertainty in its position. So the question is, if an electron is moving with a velocity 600 meters second inverse, which is accurate up to 0.05%, then calculate the uncertainty is in its position. The value which is given, velocity of velocity of electron velocity of electron is 600 meters second inverse, and we know the value of h is 6.63 into 10 to the power minus 34 second, and mass of electron, we know that the mass of electron is 9.1 into 10 to the power minus 31 kilogram. Now in this question, the value of velocity of electron is given, which is 600 meter second inverse. But we have to know about the value of uncertainty in velocity, so we can find out, because in question it is given that the accurate up to 0.005%. So we can easily find out certainty and velocity will be 0.005%, means 0.005 upon 100 into 600, which will be equal to 3 into 10 to the power minus 2. So the uncertainty in velocity, that is delta V, will be 3 into 10 to the power minus 2 meter second inverse. Now we know the principle of uncertainty through the principle of uncertainty, which is delta x into delta p is equal to h upon 4 pi. But in this question, we know the value of delta v. So firstly, we should change delta p, which is momentum, into m into v, because p is equal to mv. So delta p will be equal to m delta. So the value of delta x into m delta v will be equal to h upon 4 pi. And we have to calculate the uncertainty in its position, that is delta x, h upon 4 pi m into delta v. We know the value of h, pi, m and delta v. So we will put delta x is equal to 6.63 into 10 to the power minus 34 kilogram meter square second inverse upon 4 into 3.14 into 9.1 into 10 to the power minus 31 kilogram into 3 into 10 to the power minus 2. So the value of delta x will be 9.93 into 10 to the power minus 3. So the uncertainty in its position will be 1.93 into 10 to the power minus 3 meter, and it will be our final answer.